Hello all, welcome to the video lecture series for the subject compiler design. Now I'm going to explain you about Peephole optimization technique, right? So this is the second approach. We can see how the optimization can be done through Peephole, right? So what exactly it does? Point number one, I can specifically say that it is going to read the statement by statement code, right? So the point one, I can definitely say that it is going to read statement by statement, right? So why it is reading statement by statement? Because it may cause redundant instruction. So the objective here, you can check it, we can say that it should not have any redundant code. Okay, so that is the reason it is actually checking with statement by statement, right? So optimization here in Peephole, you can say that optimize such a target code. For example, it is applied to improve the performance, right? You can check it over here. Here you can say that the statement what we have, right, by statement for, we can say that improve the performance, right? Improve the performance of the code, right? Now not only improving the performance, also it is examining the short sequence of any target instruction, right? So examining plays an important role here. So it is also examining. Okay, third main approach here by statement in redundancy code, replacing the instruction by shorter or faster sequence. So we can say it as replacing is also adopted here, right? So the previous video I was explaining you all about principal source of optimization with several important techniques. Here it is going to have the same process but in a different angle, like it is going to improve the performance and through examining and replacing the instruction for faster sequence. Okay, right? So I can explain you all about how this particular process will take the approach, or else we can call it as characteristics of Peephole, right? So I'm going to explain all of this with the characteristics. Okay, so characteristics of Peephole optimization, right? So now basically here the first approach I can say it as redundant instruction elimination. We have already seen this, right? How this redundant instruction can be eliminated. Now I can have the redundant, so instruction elimination, right? Now basically this particular process is going to have the repeated core, or else we can call something, what to say, like eliminate the redundant, whichever is simpler you can choose it. Now say for example move r0 comma x, and also again move x comma r0. It doesn't have any reflex, right? So the same process is happening. I'm moving initially r0, that is x to r0 again r0 to x. So I can say that this particular part can be eliminated, right? This particular second line of the code can be eliminated. One more example I can tell which code is unreachable. That unreachable code is also, we can say, redundant instruction elimination. One example, this is example number one, and second example I can give like this: sum is equal to 0, right? I have initialized the value sum is equal to 0. If sum, right, if sum, and I'm going to print this statement, the percentile value and the constant whatever it is. Now you can see which particular line is or we can say that it is unreachable. This particular process is unreachable because we are not checking in this particular loop, we are not checking any of the value which is the value as initialized as 0. So this second line, specific line, you can see here, this particular line is unreachable, so that the next line will always have a dependency of the previous line, obviously. So definitely it will have no values to be printed in the output. Okay, So this is the second main approach in people optimization. We can use to call it as a flow of control. Okay. Now you can check it. Each and every process here, right? It should have a valid jump in any of the flow. Say for example, I'm going to use this three address value. So go to test. I'm going to test some condition, right? So here in test, okay, so in this condition go to done. Okay, now you can see this test doesn't tested any values which has been adopted. Now the value has been done. This is number one, block number one. Okay, now the same block can be rewritten again, right? So this block I can call it as ineffective jump. Why it is ineffective jump? Because go to test. Okay, any of the value which is going for a test, the test doesn't test any value, it is directly printing the value, that is go to done. Okay, so what exactly the flow of control and how exactly the flow of control works? Now I am going to write an effective jump. So this is an ineffective jump. Now I am going to write effective jump, right? This we can call it as what is it, like peephole presentation of any given instruction. It is going to read instruction by instruction. That is a point I was initially mentioned about peephole optimization, right? Now I am writing the same condition in different way. So for example, if a is less than b, okay, so if the condition is true, go to test. Now this will become an effective jump. Test, what the test will do, if the condition is true, then it will go to done. What the done in the sense, it is a printed part, right? Now this particular part is actually tested and it is actually printed with one particular condition. So here this part is an effective jump. So here the line by line execution or else line by line statement by statement values has been clearly observed by peephole. That is a point, right? The peephole optimization is going to recognize each and every statement, and the statement is correct and the statement is incorrect. Here you can see there is no condition has been checked. It is initially have this value, tested value. But see the effective jump, if a condition is tested, if the condition is true, and then it will go. If the condition is false, again it will go. So whichever the else part or whichever the part which is going to be printed will have a numeric, also will have an exact perfection of execution. Okay, so the third main approach you can see here, it is algebraic simplification, right? Let me tell you what is this. It is often produced an intermediate code. Okay, it can be eliminated by peephole optimization. How? Say for example, x is equal to x plus 0. There is no value for this because there is no x. Now say for example, x is equal to x asterisk 1. So you find what is the value for this. You find what is the value for this. Any value which is added with 0, the same value will come. Any value which is multiplied by 1, which is multiplied by 1, say for example 7, say for example 7, here 7 plus 0 is 7, 7 asterisk 1 is also 7, here it is also 7, here it is also will get the same result, right? So this particular exact path we can call, or else this particular approach we can call algebraic simplification, right? This simplification will be reduced. This is also a techniques. This is also a technique. We can call it as what is it, like a peephole optimization. We can optimize this also. Instead of having this code, we can keep on running the next process to be done, right? So let me take you to the fourth approach in this, reduction in strength in simple form. Okay, so reduction in strength. So we reduce the same thing, right? We reduce the same thing in peephole, principal source of optimization, but here it is slightly different. What slightly different? Let me tell you. Replace the expensive operation, that is higher strength, okay, by equal and cheaper one. Say for example, x square is the value. This is the highest strength, okay. This is the lowest strength. Can we have the highest strength for this? Yes, exactly, x into x. So which one is cheaper? This is cheaper, and this is the most expensive, right? So we can check it over here. The cheaper value will be taken. That also a kind of optimization. Cheaper will be taken. The expensive approach will always be rejected, avoided in optimization technique. Okay, this is the last approach we can see in people optimization, that is mission idioms, right? So here also you can check it. We can reduce something higher value into the lower part. Say for example, I is equal to I plus 1. Can we reduce this? Yes, it is possible. I plus plus. Here you can see this is the reduced part. I is equal to I plus 1 have two operand, one operator. But here you can check it. Here also the assignment operator is also used, but here simply it is incremented. So the second example in mission idioms, you can check it. I hope you can recognize I minus 1. So what exactly it can be? I minus minus. This is the reduced part, right? So this two approach we used to call in people optimization as mission idioms, right? So the main focus of people optimization is focused towards few approaches. That is, it is going to take any values and read statement by statement. It will improve the process, it will improve the performance of the code, and it will do the examination, and it will do the replacement. Thank you.